So, after discussing micro scale and nanoscale joining or welding processes, now we will try to look into that other manufacturing processes at micro scale. So, the development also happens in even in case of casting process. So, that is we generally call the micro casting process. So, in these cases the manufacturing process of small structure using a metal melt which is cast into a microstructure mold. So, very small mold we have to put this molten material, and accordingly we need to solidify it such that we can produce some kind of micro casting structure. So, the challenges here that what way we can keep this very small amount of the metal or maybe you can say the molten metal transferred to this specified volume. So, the example we can get the microcasting process, the instruments for surgery, dental devices and miniature devices for even for mechanical engineering. So, several small components or micro scale components can be produced by following the microcasting process. So, actually this microcasting process is basically based on these two aspects, that means development of this process. So, one is that capillary action microcasting, definitely when we want to push very small scale and we have to put a very small channel, then capillary action may be significant here for the development of the microcasting process. Second one is the microcasting based investment casting. So, conventionally investment casting exists, but the similar case it is possible to develop downscaling of this investment casting process even in the micro scale casting processes. So, based on these two mechanism, the microcasting process has been developed. If we look into in general the microcasting following the capillary action, here we can see it is a similar kind of the die casting process. So, in the die casting process we use the permanent mold, and then where the cavities of the mold is created according to the shape of the high precision grinding. So, basically the cavity is produced following the very high precision grinding process to obtain very good surface finish of a cast product. Two different principles we follow when there is a capillary action based microcasting process. One is that the melt volume of the molten material can be sucked and especially control mold and through the by the capillary pressure. So, that way we can suck this, it is possible to suck the molten material to the casting volume, or in other way also the casting alloy is melt inside and the inside the divisible mold and the fill the cavities then inside the mold and fill the cavities according to the capillary action or capillary force based on this thing. So, both way the capillary action based microcasting process can be developed, but of course, in these cases if we put the, it is necessary to put the subsequent pressure such that mold the applied to the mold, so that displaced to the excess mold and come out from these things through the slit. And normally use in the casting volume it is with a coating with the different kind of material, such that this coating is actually helps cut smoothly removal of the cast product. So, that is the purpose of using the coating on the surface. And the geometries, but one of the limitation of the capillary action based microcasting process is the shape of the geometry. So, actually geometry is limited by the application of the capillary forces. So, it is a very complicated geometry, may not be possible to produce if we follow the microcasting process and by the principle of the capillary action. So, in that case the investment casting has been developed, and in the at the micro scale, that is called the microcasting based on the investment casting process. So, microcasting is generally identified with the investment casting process. In general, the wax, it is a kind of casting technology. We know that it is a low wax, low mold technique. We just simply remove the wax from this cavity and that is filled by the molten material. So, actually this process is very accurate and near net shape product can be possible to produce by following the investment casting process, and even it is possible to create, it is a very complicated shape near net shape product with a very complex intricate, and that is why complicated forms particles of metal even with the undercut also it is possible to produce in this these cases. And other advantage of this investment based microcasting is that it is a very rapid process and very rapid process as compared to the other that means capillary based processes, and low loss of material because the possibility of recycling the runners and sprues in this case. So, that is why this basically two different methodology has been developed in the microcasting process, just we discuss in these cases. Now, if you look into the another micro scale manufacturing process, we can say the packaging. Packaging means it is a kind of normally you understand the packaging in the micro scale manufacturing processes, that what way we can package the micro and nano devices. So, from that purposes we can use this packaging terminology here. So, definitely in case of it is a very critical aspect in case of micro or nano scale devices to brings the package at the or interconnection between the different components by creating the functioning interface between these two components of a particular devices. So, let us look into what way we can do the packaging normally follow in mostly associated with the MEMS or NEMS process. MEMS means a micro electromechanical system or nano electromechanical system. So, that is here the mostly the packaging can be done using in the vacuum environment, ultra high vacuum environment possible to do. So, maybe when you try to produce the packaging of a nano or micro devices, so it become very costly when you try to follow this at ultra high vacuum environment. And packaging it also includes the terminology, the integration of these processes after the micro fabrication, what we can integrate that comes under that depends on the effective packaging of the different components. But of course, challenge remains even micro electromechanical system, what are the different components can be added or packaged, and at the same time for the nano electromechanical system. And of course, these challenges actually arises based on the specific application at which it is very difficult to generalize way. We can look into the example also. For example, the self assembled monolayer can be used to coat with the devices to avoid the moisture induced sticking problem. Then in that cases this monolayer this packaging the by application of the coating the packaging can be done also, and apart from that gaiters can be used to remove the particles or moisture inside the package. This is also another part of the packaging system, and of course, the packaging also provides the functional interface. So, interface is very important when we try to integrate the small components in a particular devices, and that small components needs to handle the micro scale or nano scale devices. So, therefore, functional interface is important to take care of during the packaging process. So, sometimes the functional interface can be created by following the specific packaging techniques, and what way the functional integration between the two components of a particular device or one device is to the between the devices and the environment, what will it is interact, it depends that it actually influenced by the packaging system for a particular micro or nano devices. So, in general a variety of the functional interfaces are needed in packaging and sometimes at different scales also. So, example optical, we can say that sometimes the interfaces may be optical radio frequency response, thermal conduction or convection, fluidics, and the mechanical mean body or surface loadings, radiation, magnetic interfaces. So, that type of different functional interfaces it is necessary to produce when you make a complicated or kind of MEMS or NEMS based system or micro or nano system. Now, another part of these things already we have little bit discussed about the machining processes, and we see that different conventional non-conventional processing can be lower the scale, and it is also applicable at the micro scale also. So, development of the micro EDM, micro milling machine, micro turning processes also. So, that has been discussed about the when we try to discuss the different in the mostly in the introduction part. But here apart from this machining process, the finishing is also important in case of micro scale manufacturing processes. So, sometimes the finishing may be requirement at the micro scale such that surface roughness is necessary to produce at the micro scale or a nano scale. So, therefore, that is based on that micro or nano finishing processes has been developed. We can see that traditional micro finishing may be look into that grinding process, lapping process, honing process, we can achieve up to certain the surface finish of the micron level, a micro scale. But if we look into that advanced finishing operation, we can get the different processes normally used for the advanced finishing operation process, AFM, abrasive flow machining, then in the MAF, magnetic abrasive finishing, that is also one kind of the advanced micro nano finishing processes. Then magnetoreological finishing process, chemical mechanical polishing process. So, magnetoreological abrasive flow finishing. So, in these cases we use the magnetic particles here, so that means flow of the particles should be influenced by the magnetic field. Then electrolytic in the process, dressing, that can also be used, and the magnetic float polishing, that also as that process has also been developed. So, here we can see to achieve a very good surface finish which sometimes required in a very precision, we want to develop micro or nano devices. So, sometimes the finishing process is also important aspect there. So, to achieve particular finishing, particular surface roughness of a machines or manufactured product, we normally follow the different finishing processes. Just I have mentioned all the different types of the micro nano finishing processes, but of course, if we want to achieve the micro finishing, probably we can go for traditional grinding, lapping and honing process, but if we want to go nano finishing process, so many processes has been developed that here we have discussed and are listed in the right hand side here. So, apart from the micro finishing, then there is another manufacturing technology at the micro scale development happens in case of micro forming processes. So, metal forming process, we understand that we try to deform the particular material with the desired, getting the desired shape, that is in general called the forming processes. But when it is technology to handle very small intricate particle, metallic particle resulting from the microsystem technology, they are also necessary to particular bending or maybe some sort of other product can also be developed, and that is done by the microforming processes. So, in general microforming processes associated in the 4 basic steps, the what material we are handling for the microforming process, then what are the processes? Processes mean whether this is bending or other forming processes, then design of the tooling, and then you die, all this is necessary to design, and the what machines tool we are using. So, all these 4 parts is associated with the microforming processes. So, if you look into the micro sheet metalworking processes, normally blanking and bending processes. So, examples is the connectors, contact spring, leaf frames, and which is produced by this micro sheet metal working processes. So, in these cases mostly metals are associated with the copper alloy and iron nickel alloy is used basically the spring hard state to prevent wrinkling and crumpling. So, in that cases this type of metals normally handle, and which is get the application of the microforming processes. So, shearing of the cutting blades for the shapes and punching of the holes for fuel nozzles of engines in around the other kind of this blanking process. So, here it is possible to create the hole about the 50 micrometer diameter, in that range it is possible to produce by following the microforming processes. Bending, deep drawing, stretch forming, these are the different types of the processes has been used in even for the sheet metal micro metalworking processes, but in these cases the example is the cups for the electron gun or shafts for a small motors we have to produce, that actually associated with this kind of manufacturing processes, bending, deep drawing and stretch forming, of course all these cases, and that is in the micro scale process. Even bulk metal is also possible to handle by microforming process. So, in these cases microforming process is wire bending for the production of the filaments. So, we see the filaments and the springs as used in the medical applications and the electronic industry. So, there from the bulk metal this microforming process is also applied for this particular application. Apart from that, even its wire drawing processes, The very small production of the very small wire is very challenging task, but in this cases is produced from a bundle of the wires, which is embedded through a skin and is drawn together with the skin. So, about 5 micrometer diameter is possible to drawn by following the micro drawing processes, and it is possible, and where the conventional method it is about 15 micrometer. So, that is if we use a specific process in these cases. So, it is possible to achieve around 5 micrometer wire diameter as compared to the conventional 15 micrometer diameter is possible to produce in case of microforming process. Even thin foils, if we see the copper alloy, nickel, silver alloy can be produced with a minimum thickness of the 6 micrometer to 10 micrometer is possible to produce by following the microforming process. So that is why thin foils is normally followed, it is possible to produce in from the microforming process. So in principle we already discussed the different forming processes, but in these cases we just try to highlight that these are the different processes, and even it is possible to develop all these micro scale forming processes. Just we have discussed few of them. So thank you very much for your kind attention. So in this module normally we discuss that micro and nanoscale manufacturing process, but I have tried to give some overview of all these processes. So thank you very much.